位现场的媒体朋友，还有各位来宾，大家早安！我们今天记者会再过1分钟之后开始，请大家就座，也提醒各位将手机关机或是转为震动模式。我们今天的记者会当中有提供同步口译的服务，中文请选择第1频道，英文请选择第2频道。如果有需要的来宾，可以到我们的报道台索取同步口译的耳机。Ladies and gentlemen, we will begin the press conference in just 1 minute, so please take your seats. And once again, please switch off your cell phones or to silent mode. Thank you for your cooperation. 各位亲爱的媒体朋友，还有各位贵宾，大家早安！欢迎各位莅临ARM 2016 Computex 的展前记者会。很高兴今年又在 Computex 跟大家见面了。在今天的记者会当中，我们非常难得邀请到 ARM 的高层主管来到现场，跟大家分享 ARM 的最新消息，还有产品的技术。Good morning, ladies and gentlemen. Welcome to ARM's press conference at Computex 2016. Very happy to see you all again. And today in the press conference, we'll be hearing from top executives of ARM who will be sharing with us the latest updates as well as exciting announcements. 我们在今天记者会一开始，我们就欢迎 ARM 执行副总裁暨首席行销业务长 Rene Haas 来为我们致辞。So now I would like to ask you to join me in welcoming Rene Haas, Executive Vice President and Chief Commercial Officer of ARM. Rene.
Good morning and ni hao. Welcome to our press briefing. Very much appreciate you taking the time to join us this morning. You know, as I was thinking about this show flying over here, this is my 10th Computex. It's not my 10th here in the industry. I've been around a little bit longer than that. But I was thinking about 10 years ago when I first attended the show, what were some of the key themes, but more importantly, what were the devices I was bringing, with me in my briefcase at the time. I don't think we were using backpacks. And I remember the biggest theme at that show in 2006 was the fact that laptop computers were just starting to overtake desktop PCs as the primary computing device. And at that time, Computex was really a show that was largely around the PC ecosystem, whether it was the OEMs or the ODMs and all the things that make Taiwan sort of the rich community that it is around this industry. And I was thinking back, I think the phone that I had with me at that time was a Motorola flip phone, a StarTAC, that if you wanted to text message somebody, you had to be really, really good at knowing the combination of keys that would sort of get your message out. So, 10 years later, to be here talking about the launch of some new products that we're going to share with you today, really struck by the change that's happened in this industry, and particularly as it impacts Computex and the show here and the things that we're doing. Obviously, we're going to talk to you about today are some of the new products in the mobile space, which is a space that we continue to see huge growth and huge opportunity. And it goes without saying, and I think we all know this now that we have, obviously everyone in this audience for sure has a smartphone with them. I had two. So when you look at the use cases in terms of numbers, they're huge, right? And when you look at the numbers relative to what is going on with the smartphone, the numbers alone are just staggering. And it's really an output of what the smartphone means to us in our daily lives and how we use it. And again, if we just look back a number of years to think that the amount of computing power that was in that laptop 10 years ago is far surpassed in terms of what's inside the phones today. Is pretty staggering. And with that, the smartphone is really the Swiss Army knife, if you will, of all things computing. It is a device that you can get sports scores on. It is a device that you can get a taxi. It is a device that you can obviously work on. It is a device that you can, lo and behold, make phone calls. Right? So it is a platform that has so many different use cases that can be applied in so many different areas. It's really just, we think, at the very beginning of some interesting use cases going forward that we're going to talk about today. And and with that, when we just look at just the numbers, 3 billion smartphones that are ARM-powered that are in the world today. If you do the math relative to whether it's north of maybe 7 billion people on the planet, 3 billion is a pretty large number. So you ask yourself, well, are we starting to saturate? Well, I have 2, so maybe not. You can read the growth numbers here in terms of the population, in terms of what's driving the use cases. And again, if you look at the demographics in terms of some of the younger audiences. But I think more important than just the numbers of people who use the phones, you start thinking about, well, what's going to really drive growth in this market in the future? Is it more people who are just going to replace their phones, or are there use cases that are going to really drive innovation? And that's what we are going to talk about today with some of the new products that we're launching, because we believe that right now we are looking at some really, really unique use cases around mobile computing that actually even 12 months ago were not something that we thought was possible to be done on the mobile platform, that we're really super excited about. And I think one of the things to keep in mind, again, as we talk about these new use cases, is the fact that building on top of this mobile platform is really a natural outcome. When you think about the software investment, when you think about the number of different partners in the ecosystem, some are here with us today, it's obvious that the mobile platform is going to be the platform for growth in these engines. And it's really only in mobile that some of these use cases can get the kind of growth and adoption, because the platform is so ubiquitous, it's used by so many folks. The developers are tuning applications for these platforms. So then when you think about these new use cases, it's really a sort of a natural outcome that mobile will be where it's at. So some of the cases I'd like to talk about today, and again, Nandan, when he goes through his presentation on the product side, we'll talk about a little bit why this is so important. Again, these are areas that even 12 months ago we might not be considering as real use cases for a handset. One is in the area of augmented reality, and I'll talk a little bit about what those use cases are. Gaming. Obviously, gaming is a use case that's existed on mobile, but when you start thinking about now the resolutions that are involved, the kind of performance that can be done, the kind of things that people do on their handsets with gaming, we're ushering in a brand new era, particularly when you give the fact that these kind of high-end performance applications require low power, small footprints. We can do some very innovative things. And then virtual reality. Obviously, virtual reality is a very hot market. There's a lot of buzz around it. We're going to talk a little bit about some things that ARM is doing in that space. So first off, I want to talk a little bit about graphics virtual reality. This chart here that you take a look at on the left-hand side shows a little bit of the subsystems that are required inside a handset to make graphics virtual reality go. And the first thing that sort of strikes you is that the area for the CPU and the GPU are on and highlighted. Doing virtual reality in a graphics space in the handset requires a lot of CPU horsepower. It requires a lot of GPU horsepower. It requires, obviously, memory in terms of all the data you're moving. And it requires a lot from the display processor. So Nandan, again, will go through a lot of detail on this, but graphics virtual reality and the use cases around it, we're bringing some of the subsystems to this world today that will address these solutions going forward. And it's very real. There's a demo back there. I hope you have a chance to use it and take a look. I would warn you that maybe hopefully your meal has digested before you try that, because it's pretty real. And this space is going to, we think, really launch a brand new set of really, really interesting sets of applications. And if you can do that around the mobile platform, again, where the developers have a very rich set of experiences that have already been tailored to the platforms, the growth will be really significant. Now, when you add on video onto that, again, if you look at this little chart that talks a little bit about the use cases, now you've got the CPU, which is helping do some of the work. GPU, maybe not so much work in this case, but you actually need a video engine, a video processor that can help you with all the work required with video virtual reality. You can read some of the modeling there from a 3D standpoint, but doing video on a mobile platform for VR takes a lot of work. There's a lot of energy required, there's a lot of performance required, there's a lot of use cases that demand a real high degree of performance. The mobile platform, again, is well tuned for this. It's established. We have a lot of use cases that have already been proven, and this is an area where we think developers will be doing a lot of work in the future. So gaming. So when you think about gaming, you think about rich titles, AAA titles, the very best titles that people want to run. Again, this is something that's now just finding its way to mobile. It existed in the high-end world, in desktop, and laptop, and now it's finding its way into mobile. And the reasons for that is a lot of innovation going on inside the GPU, where now you can have a tremendous amount of performance in a power envelope that doesn't drain your battery. So these AAA titles that people are used to playing on high-end consoles or playing on laptop PCs, people want to play these on all their platforms. People don't want to be restricted to just a single platform. People often use those cases. This is an area where having a mobile GPU that can be very, very efficient on power, very, very efficient on doing innovation relative to accelerating titles, whether it's around 3D, is a very, very significant use case. And another very interesting use case is around 4K video, and this is in the area of not only capturing images, but doing post-processing or anything around image manipulation. And in fact, just last week or a week or so ago, we at ARM announced the acquisition of a company based in the UK called Apical that's doing work in this area in the space of image processing. We think this is a huge growth area for the mobile platform. If you look at what's required from a performance standpoint or what's required from an implementation area, you can see all the areas of that handset area are illuminated. What does that tell you? There's a lot of processing that's required to go off and do this. And when you have these very, very large 4K images that can capture a very, very wide area, you also want to be able to do post-processing and editing of the images after you've actually captured them. With this type of resolution and this type of capability inside the handset, now end users are going to be able to do some really, really exciting things around 4K video and imaging. Augmented reality, again, it's really interesting that these are use cases, whether it's VR or we're talking about post-processing or gaming, and now augmented reality, that you can do inside a handset. Augmented reality, for those of you who aren't familiar with it, is the concept of adding information onto a existing scene. So let's say you're walking down the street, you've got your handset, and you want to put your handset up and find out where the next Starbucks is. And those of you who know me know that's a very real use case. With the augmented reality case, you can just put your handset up, and it will map out for you in terms of what's ahead relative to locations. So you don't need to go into your handset, you don't need to type in where is Starbucks, you don't need to do anything via voice, you can just literally hold it up. This is not a new technology in terms of technology that's been implemented on higher end platforms that have been talked about in the past few years. But what is new? It's finding its way into mobile. And when you think about augmented reality as a use case in driving growth and driving innovation, it's a very, very real example of things that people will do. They'll find value from it. And again, yet another example of where the smartphone is the platform to develop this on. From a performance standpoint, you can also see that it requires a lot. There's a lot of heavy lifting that's required by all the elements of the subsystem, whether it's a GPU, whether it's a CPU, whether it's the video area. These are all areas where ARM brings a lot of leadership to this space. So it's, and again, Nanda will talk in more detail about this area, but it is a space that's very, very key for us. So, with that, we are very, very bullish actually on the smartphone market. There are people who will debate whether we've seen peak in this area. We actually think what drives growth is use cases and new areas of innovation. And we actually think in this world we're seeing a tremendous amount of growth and unique applications. And the ones that we just talked about are actually some of the most exciting ones that I think we've seen in a very, very long time. And it's going to drive some real interesting opportunities. So just if you look backwards a little bit, relative to what the performance benchmarks have looked like, and again, this is pre-my first, or post-my first Computex, this is 2009. You look at some amazing performance gains in the platform. And I think this is important to look at on two vectors. One, it allows us to stand up here, or at least allows me to stand up here and be proud about what the company's accomplished, what all of our dedicated engineers and engineers have done. But I think it also lays claim to this is a platform that has a lot of innovation built inside it in terms of performance. So if you think about the use cases that I just mentioned, in 2009, obviously you wouldn't be able to have any of those use cases we described in this platform. Fast forward to now, and then you were to go maybe another 5 years forward, start looking at some incredible innovation that can be done on this platform. So given the fact that there's a lot of work that's being done in innovating on these new engines, there's a lot of work being done in terms of pushing the process to get really, really good performance and really good area and power. These new use cases, I think, are just the tip of the iceberg relative to what's going to drive growth in this market. And if past history has shown us anything relative to the smartphone market, is that innovation can happen at an amazing clip. So with that, I will now hand it over to my partner Nandan, and I told him I was going to try to pronounce his last name correctly. I still don't think I can, so I'm going to cut this from Nandan N, and let him take the next piece. Thank you.
So, thanks to Renee for, one, not trying to butcher my name. My name is Nandan Nampally. I'm VP of Marketing and Strategy for the Processors Group. I'd also like to thank Renee for kind of setting up both the opportunity and the challenge of the immersive use cases of tomorrow. But before we go there into the technology portion, what I'd like to do is take a moment to reflect on how far mobile visualization technology has come. The video you will see demonstrates ARM's enlightened global illumination technology running on a Mali GPU in a standard smartphone available today. Just look at how you have very realistic visuals, lighting, shading, etc. Just let's take a look. Now this is what Renee would call the digestible format. If you want to actually have a full experience, you have the demonstrations here, but also we'll be showing that on our Computex booth for the next 3 days. And what required literally a high-end graphics workstation and expensive software is now delivered as a completely untethered experience in a smartphone, and of course running on something like a Mali GPU. Now, speaking of Mali GPUs, let's look at the numbers. We as a partnership have made Mali the highest shipping GPU. It's the #1 GPU in the world today by numbers. Over 750 million units shipped in 2015, which is a 30% jump from 2014, and nearly a 15x jump from 2011. So we've come a really long way in a very short time. That's again part of how we work together. And from ARM's standpoint, this success we believe is because we've been listening not just to the technology itself, but the needs of the market. Right? It's not just about graphics performance. It's about solving system congestion issues. It's about putting compute together. It is about solving the software ecosystem issues, all the while looking at how to increase efficiency. And if you look at that, we look at the kind of approaching immersive needing another big step. And for that big step, we had to take a change and a step in the architecture form. So Bifrost is our next generation GPU architecture. And I'll get to that in a little bit, but it's useful to see our evolution over the last 6 to 7 years with our graphics architectures. So in 2010, it was a much more granular image, 720p with the Woodguard architecture, still a very, very popular product. The Mali-400 is built off of that. We started bringing in GPU compute and larger resolutions, 1080p and up, with the Midgard architecture. The Mali-T600, Mali-T700, 800 families are based off of that. And now, even though those higher resolution images are coming in, it's still more of a consumption situation. For the next step, I think we need to go a little bit further. That's what Bifrost brings. And remember, as we're trying to do this, with more performance, with more capability, we still have to focus on efficiency because it's, after all, a mobile format. And Bifrost brings with it a lot of innovations to support that. If we look at what we're trying to do, deliver more performance and more efficiency, we can classify that into 3 major areas. So the compute aspect of it, the system aspect of it, and the software. And just for making it a little bit interesting, we go left, then right, then center. So in terms of the compute aspect, firstly, Bifrost brings in a more advanced scalar architecture. It's a new instruction set. But we've focused on things that make it more interesting. Clause shaders enable us to compress more instructions together with less overhead. Index-driven vertex shading will help us actually push a lot of the shading towards the end of it, actually reducing the amount of actual work we need to do on it. And then, of course, we've designed it with local registers so you can actually reduce the amount of wire lengths as you build these GPUs. And especially in new process technologies, wire lengths, as you know, are critically important. Now, moving to the right side, the new use cases are not just about pure GPUs. They are a lot more interactive with other components on the system on a chip. And so a lot of interaction with the CPU. And the Bifrost-based components will be the first ones to have full heterogeneous capabilities. So you can use the same virtual memory system that the CPU uses and actually not worry too much about sharing data across. And more importantly, you have less of it going off-chip. And off-chip is actually where a lot of memory effort and a lot of power is spent, and we're reducing that. And then finally, trying to make the software developers' life easier. Bifrost was designed from the ground up for Vulkan, which is the API behind a lot of the new content being developed. And with a very optimized backend for it, it makes the software developers, the game content developers' life a lot easier to bring content to market faster with the kind of performance and efficiency we need. Now, with Bifrost as the foundation, we can announce our first Bifrost-based product, the Mali-G71 GPU. It's targeted at delivering at least a 50% improvement in performance over today's leading premium GPU from ARM, which is the Mali-T880. Now, remember this, it is also the most scalable GPU. The 50% we talked about is based on a 16 shader configuration, but we know this is only going to need more performance as we go up, and Mali-G71 has been designed to go up all the way to 32 shaders. So there's a lot more upside in the performance on the Mali-G71. We also expect the Mali-G71 to first hit premium phones with SoCs designed in 10 nanometer technology. And that's where you'll see a lot of its key value references. But in spite of this, it is still independent of process technology. If we took the Mali-G71 and compared it on the same process technology versus a Mali-T880 today, it still delivers over 20% energy efficiency, meaning you're taking 20% less energy on the same process technology versus a Mali-T880. It can, of course, scale up to 32 cores, but that's independent. Here's where it becomes that much more interesting. we take 40% less area on the same process to deliver the same level of performance. And as you can see, you need more and more of this compute. You need to make space to be able to fit more of this GPU capability in it. And that's very important. And last but not least, it reduces the external memory bandwidth by 20%. And again, as I said, the more you go off chip, the more power you burn. We're trying to reduce all that as we get to these more immersive use cases. Now we've compared it against our premium GPU. Let's compare it with things that you might recognize on the market. Right? What we've run here is benchmarks based on the GFX Venture at Manhattan, which are very immersive use cases, or actually very taxing on the GPU, and compared it against laptops, mid-range laptops of 2015. And what you see is a 16 shader configuration of the Mali-G71 matches the performance of a discrete laptop. And versus an integrated GPU laptop, it has a comfortable lead. Now the thing to note is, even if you look at the more compact laptops, you're talking about a 25-watt SoC versus a smartphone SoC that's 4 watts, or realistically more 3 watts. So you're delivering the same level of performance in almost an order of magnitude less power, and that's really important. Now, if you look at what it can do now with this kind of performance, you can see where it's going in terms of augmented reality and virtual reality type applications. And as we get there, the constraints only get more, stringent. If you look at what you need in a situation like this, certainly for a realistic VR experience, you need higher frame rates. 60 hertz is what you see today. It'll probably get to 120 hertz, especially in more motion-oriented virtual reality. Resolution goes to 4K pixels. As they get closer to your eyeballs rather than the screen, that becomes that much more important. And if you're talking about a truly interactive experience, you have to minimize the latency, let's say from the head motion to photon delay, for the real sense of realism that you expect from it. And putting it all together, when you've got everything close to your eyes, you start seeing edges, jagged edges a lot more, and that's where the anti-aliasing aspects of the Mali GPU come in very handy. These are done and within the architecture extremely efficiently. Now that's a lot of performance improvement, right? Or that's what's demanded. But also now in a virtual reality situation, you're not going to be designing it for one screen. You design it for 2 eyeballs, so that effectively doubles the need for that performance. You have to do all that and stick within the same power budget, because your phone size is not changing by much, and the same thermal budget, which is actually that much more interesting. And just to put it into context, and if you go to the display over there, you'll start seeing the phones that as they have evolved. You look at 6 years ago, the HTC Nexus 1, 12 millimeters thick, not bad, it's actually a very compact phone. You see the Huawei Mate 8 this year, under 8 millimeters thick. What was, by today's standards, a very basic gaming experience on the 12 millimeter phone to effectively a VR quality experience today on the PA. So you can imagine how much more you need to do to make it as efficient, to fit in to those thin phones, because you don't have any leeway in terms of the amount of heat you need to dissipate. Okay, we're talking about how the GPU is getting efficient to support that. We need the rest of the components on the chip, the CPU being a major one, to do that as well. So to marry up the G71, we're also introducing the Cortex-A73, which is our most efficient big ARM CPU that we're to date. It delivers over 30% improvement in performance in a constrained mobile budget, and I'll get into that a little bit. It doesn't seem like a big amount, but it's actually a lot. Also, to keep this going, we need to make it more energy efficient. So we think about it as 30% more energy efficiency to be able to deliver that kind of performance in the same budget as well. And in the target 10 nanometer technology, this premium CPU, fully with level 1 cache as a single CPU, with a neon, etc., will be less than 0.65 square millimeters. That's just a little over half a square millimeter of die. Now, putting into context what this means in terms of actual delivered performance, we try to compare the performance of the last 2 or 3 generations. The Cortex-A72, which is in the main 8, is still established as a leader in performance and efficiency. And in these graphs, what you're showing is the dark part of each of these bars is the amount of performance delivered in a 750 milliwatt envelope, which is what you need to be able to constantly sustain it. And to René's point, the interactive visual experiences are not going to have just bursty interaction. It needs a constant level of performance. So the A72 took a big leap over the A57 and 20 nanometer, and then the Cortex-A73 actually delivered a 50% boost over what the A72 could do. And if you just cap it over 2 years, that's nearly doubling the performance that you saw in 2015, all in a very sustained smartphone budget. So that's a pretty big jump from the last 2 years, but we've been doing it over the last 4 or 5, and that's why you're able to fit in to René's graph, the phone from 2009, 2010, all the way up to here. So to give you an example, we try to show the level of performance uplift that has gone on over the last few generations. We've purposely taken the comparisons against the Cortex-A7 processor. For one reason, it's in some of the most popular smartphones. It's shipped over 2 billion units so far, and a very competitive base level of performance. Compared to that Cortex-A7 and 28 nanometer, you see where the Cortex-A15 was about 2 times the performance, the A57 going a little over 3.5. The Cortex-A73, each core will deliver about 6 times the performance off that Cortex-A7. Now that's good, but it wouldn't be possible in the same budget if we weren't also reducing the power consumed for each task that it does. And what this tries to show you is the level of power savings doing the same tasks as the previous generation Cortex-A7. And what you see in the blue line down there is that in 10 nanometer for the same task, it would actually consume less power than the Cortex-A7 did in 28 nanometer. Now that seems okay, that comes from process technology, you would expect that. But if you look at the purple line, you're still seeing a substantial drop even if we kept it in the same process technology. So in 28 nanometer, the Cortex-A73 is still less than just 2x of what it was, while delivering effectively what could be 6x the performance. So our focus is on not just delivering that performance uplift, it is also on delivering it efficiently so you can actually achieve these immersive use cases. Now it's not just about the CPU and the GPU, you actually need to put it together into an ecosystem, an SoC that actually works. Right? So the first thing you need to tie it together, you have a coherent CPU, a coherent GPU, all with big bumps in performance, need to have an optimized path to memory and an optimized path to communication between the two. And that's where the CCI 550 components come in. We announced that end of last year, and it offers about a 35 to 38% improvement in latency going from the CPU or GPU to memory, but also more importantly, because of the coherency being efficiently done, you save hundreds of milliwatts of power because you're not going off chip as much and you're efficiently communicating between a CPU and GPU that are interacting much more closely now. And you've got the base infrastructure in, now you put it all together. ARM SoC components are designed with the CPU, GPU, and other IP in mind so that when a partner takes it, they have been tested. You can start off at a much stronger footing and help to get a more efficient design to market quicker. And the infrastructure includes things like trust zone for security, and now we've got more IP that will help us do more advanced vision, adaptive displays, assertive displays, and more. And finally, underneath all that, we have the POP technology to help you achieve the key performance and power goals that you have to achieve your market position. So, where are we today with the signing of this? We have over 10, we have 10 licensees on the Cortex-A73, 9 on the Mali-G71. Obviously, not all of those are seen on this chart. And we're lucky to have some of the representatives from HiSilicon, we're honored to actually have them here. Also MediaTek and TSMC, who are local partners and recently worked together on demonstrating the Cortex-A73 in a 10 nanometer test chip together. So it is getting real. In fact, we will see silicon by end of the year, early next year, devices certainly by 2017. And those are the devices that we believe are putting together your smartphone, which is the portal for your future use cases. Right? So Cortex-A73, at least a 30% improvement in sustained performance delivered. Mali-G71, at least a 50% improvement in performance delivered on the new Bifrost architecture. And we're focusing on the key technology trends that will give you the immersive experiences of virtual reality, AAA gaming, and augmented reality. Thank you.
Thank you, Nandan, for introducing to us the latest CPU Cortex-A73 and the premium IP Mali-G71 graphics processor. 非常谢谢 Nandan 刚刚跟我们介绍 ARM 最新的产品还有技术。And now we would like to proceed to the protocol and the ceremony today. 我们接下来进行今天的重要仪式。We would now first like to invite Renee to once again come up. And also we would like to invite ARM's ecosystem partners. 我们也要邀请 ARM 的重量级合作伙伴到台上来进行今天的仪式。首先欢迎联发科技设计技术研发本部总经理王世安博士，联发科技资深副总经理陆国宏博士，台积公司业务开发处处长李玉君博士，以及海思图灵业务部副总经理刁延秋先生。So we would like to invite Dr. S.A. Huang, General Manager of Design Technology of MediaTek, Dr. K. Lawrence Low, Corporate Senior Vice President of MediaTek, Dr. Li Yujun, Director of Business Development Division of TSMC, and Mr. Diao Yanqiu, Deputy GM of Turing BU HiSilicon. So now we would like to ask our guests to smile for our cameras and our journalists, leading through partnership. 我们就请在现场的贵宾为我们的摄影记者微笑一下 ，leading through partnership。Thank you very much。我们是不是再一次掌声？谢谢台上的贵宾。我们邀请台上的贵宾稍微留步 ，Please remain on stage for a few moments. We would like to invite you to join us for a toast. ARM 一直持续的合作，跟我们的生态系合作伙伴共同打造具有创新还有竞争力的生态系，促成万物相连，共创智慧未来。So now we would like to ask you to raise your glasses and again a big smile for our cameras. 我们先。就是右手可以举起来 ，so raise your glasses once again. 好的 ，and also let us dream to a better connected future. 3, 2, 1, cheers. 万物相连，共创智慧未来 ，leading through partnership. Thank you once again. 再次谢谢 ARM 的生态系的重要伙伴，再次谢谢来自联发科、还有台积电、还有海思图灵的几位贵宾。Thank you very much. 非常谢谢各位贵宾的加入还有支持。So Nandan and Renee, please remain on stage for the Q&A. 那么我们请其他的几位贵宾回座，也谢谢大家。So ladies and gentlemen, we will now open up the floor for Q&A. 我们接下来进行今天媒体提问的时间。Please put your hand up if you have a question, and our staff will hand you a microphone. 所以大家要提问的话，请举手，可以用中文或是英文发问。我们的工作人员会递麦克风给您。We have a question over here, gentleman in the black suit.
I think we're all in black suits. Hi guys, Ian from Anteprima. On one of your slides, you showed Spec 2K numbers on the 10 nanometer silicon. Is that simulation or actually testing past with Intel parts?
Good question. So actual projected numbers at the end are estimated, but based on actual simulations and effectively correlation with both RTL as well as silicon.
Is how accurate are those simulations? Are you doing them energy accurate or just signal accurate?
Sorry, what is that again?
Are you doing them signal accurate or energy accurate simulations? Or both?
Not quite sure what you mean by that, but these are performance accurate numbers.
I had another question about your heterogeneous support. I'm surprised to see no mention of HSA and the spec, and if there's any integration of HSA, or can you speak to whether you're being integrated with HSA, because you are a major partner. So.
In terms of HSA, effectively we are effectively state compliant, right? So in terms of when the spec comes out, we'll have as needed.
So can you say which spec you're aiming for?
I might have to defer that to Mr. Hutchinson over there. We should be able to.
Thank you.
Thank you. Let's take another question in the back.
Hello there, Leo Warlock, Kit Guru UK. You said the G71 matches the 2015 laptop with discrete GPU.
Yeah, so this is based on the NVIDIA GeForce 9400 GPU alongside a Core i5.
Thank you.
Just a reminder to those of you raising questions, please identify your name and also affiliation. 我们请现场的媒体也请提下自己的大名跟媒体的单位，谢谢。
你好，我是那个西泰斯的嘉彦，我这边想要请教一下，因为刚刚有提到，就是说他们的产品在这两款新产品其实都是符合所提出来的速度都是在4奈米的部分。那我们也知道，就是说他们跟台积电的合作其实已经进展到7奈米，我不晓得说在这两款产品这一部分会有7奈米的一些情况吗？这是第一个问题。那第二个问题，我想要问一下，就是说，新款的 GPU 发表之后，ARM 对于这款新款的 GPU， 在未来的3年内有没有什么一个预期的一个市场目标？以上两个问题，谢谢。
My name is CY, and I have two questions. So you talked about ARM's products making use of 10 nanometer technology, and that you're working with TSMC. And to my knowledge, you used 7 nanometer technology with TSMC previously. So will 7 nanometer technology still be applied? That's the first question. The second question is, you talked about the newest GPU, G71. So what are your expectations or projections for market development in the next 3 years?
Okay, so I'll try and take it step by step. So just wanted to clarify, we've been working with the likes of TSMC on 10 nanometer for over 2 years now. So what we talked about with the test chip, as well as what is expected in production, 10 nanometer going forward. In March, we talked about how we're working with TSMC and partners to go into 7 nanometer, which is obviously further out. We expect 7 nanometer will succeed 10 nanometer, and we are continue working with them for that. Now, the second question seems a bit more open-ended in terms of market development. I think the capabilities that we bring with the G71 opens up new use cases. Now, it could still be done with phones, but you could see other devices coming off of that as well. So I don't think we have a clear projection of how that volume increases, apart from the standard things that you can actually see from a lot of this, publications on projections on VR class devices.
Yeah, to one thing I might add on to that too is with the acquisition we made of Apical, it's very, very clear that we think that anything regarding the visual experience is extremely important for the mobile platform. So investing heavily in those areas is certainly an area we're looking forward to, and the Apical acquisition, I think, is a good indicator of that.
Thank you. Yes?
Hi, my name is Kazuki Kasara, PC Watch from Japan. I have a question about the A73 microarchitecture point of view. So what is the main differences between A72 and A73? So could you give me more detail?
Sure, I'll try to keep it short, but in the gist, we've actually gone slimmer on the Cortex-A73. I've gone from actually a 3-wide machine to a 2-wide machine. But we focused on getting performance while getting more efficiency. So it has a much more improved memory system, a better branch prediction capability, but it still uses all the big data path features that A72 had, like Neon. So overall, we've gone slimmer, but delivered more performance while improving efficiency.
Thank you.
Thank you. I think I saw a hand go up to my right-hand side.
It's Utsuki from Nikkei Electronics. I have 2 questions. First question is very simple. GPU process generation is what? Is 10 nanometers right?
Sorry?
GPU process. Mali-G71. The process technology is 10 nanometers right?
So Mali-G71 is independent of process technology. We expect premium devices first will see it in 10 nanometer, yes, but it is equally capable of being implemented in 16 nanometer or in the future in 7.
Next question is, I could find an important company name, Qualcomm. Qualcomm should be an important partner with the company. Why right now you cannot disclose the company name?
It's a good question. We're really only able to talk about companies that have agreed to be announced publicly at this time.
Thank you. We'll take another question. Any other questions from the floor? Yes.
Hi, I'm Hiromoto from Japan Bifrost. My question is about CCI 550 interconnect. You said it's a fully coherent interconnect. So does that mean a CPU core can snoop GPU cache, or CPU core just or skip GPU access is just skip or GPU cache?
So it is fully coherent. So both can snoop each other.
Can snoop.
Both can snoop each other.
Thank you.
Thank you. Question in the back.
Hello, I'm SK from South Korea, and I want to ask you to Mr. Nam Pali about VR and AR, about Mali. And my question is, do you have any talk or make call with about any partnership about to VR AR companies about the optimization, about performances or efficiency, about to make VR and AR performance?
So there's no formal partnerships that you're talking about, but we collaborate very closely with our ecosystem, and our ecosystem is our partners that actually build it, as well as firmware vendors, software vendors, and developer community. So we are working with a lot of people in that community to make sure that both everything we design and also the tools we provide will make it more optimized.
Any companies about the VR or AR companies talks to them?
Well, maybe we can take this a bit offline because there's a list you could come up with. I don't know where to start on that one.
There is a big list.
All right, we'll take this offline. Any other questions? 我们现场还有其他的问题吗？ All right, if not, let us thank once again Renee and also Nandan. 我们再次谢谢 Renee 跟 Nandan， 谢谢。我们今天的记者会到这。